This is video on approximate integrals. Normally in integration we have different formulas for different functions. But there are certain functions that mathematicians have not been able to get formula for. Hence, for such functions, the only way to get integral values are to use approximate method. And there are two common methods usually used. The first is the trapezium rule. It is assumed that graphs can be converted to series of approximate trapeziums. So there is a function. So let's say this is a graph. So mathematicians assume that we can divide this graph into approximate trapeziums. So depending on the degree of accuracy we want, we can divide into several numbers. The more the division, the more accurate the result will be. But for for saving time, sometimes we use small divisions. So look at the various divisions I have there. Each one looks like a trapezium. Each one looks like a trapezium. So in this case, we have divided this graph into 1, 2, 3, 4, 5, 6, 7, 8. 8 trapezium. But note, how many coordinates do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 coordinates, 8 trapeziums. So the number of trapeziums that will be obtained if we have n coordinates will usually be n minus 1. That means if we use 5 coordinates, we'll have 4 trapezium. If we use 6 coordinates, 5 trapezium. 10 coordinates, 9 trapezium, and so on. And generally, the area of a trapezium is the sum of the parallel sides times perpendicular distance. So area, that's half the sum of parallel sides times perpendicular distance. So let's see. So on each side here, the vertical lines are like the parallel sides, while the interval between the x values are the heights. So the interval between x value there height. Distance from here to here is like A. Distance from here to here is like B. Now the value of A will be the value of y when x equals to x1, and the value of B will be the value of y when x equals to x2. So the height of each line is the values of y at various values of x. So that means line 1 will have value y1, line 2 value y2, line 3 value y3, y4, y5, y6, y7, y8, y9. So the area of the first graph, therefore, area of the first graph will be half the sum of the parallel sides y1 plus y2 times the height. We are going to divide into equal heights. So the interval between the x values will all be the same. The intervals will all be the same. Area of the second will be half of y2 plus y3 times I. The third graph will be half of y3 plus y4 times I. So if you notice, a pattern is created. The fourth will be half of y4 plus y5 times height. Fifth, half of y5 plus y6 times height. 7, half of y6 plus y7 times height. And 8, half of y7 plus y8. 1, 2, 3, 4, 5, 6. Okay, this should be 7 times height. And the eighth one, half of y8 plus y9 times height. So if we add all these together, what do we get? So the area under the curve, will be integral of y with respect to x between x1 and x2 of the sum of all these areas. And if you notice, what is common to all these areas is half of the heights. Half of the heights are common. Then all the y values we now add. So let's add the y values. y1 plus y2 plus y2 plus y3 plus y3 plus y4 plus y5 plus y6 plus y6 plus y7 plus y7 plus y8 plus y9. So the area under the curve equals to integral between x1 and x2 of y dx equals to half times the height. Now note, all other values of y duplicate except the first value and the last value. Okay, there is an omission here. There is somewhere here, something is missing. Y4 plus Y5 is omitted in between them. So this will be half of the I. Y1 plus Y2 plus Y2, 2Y2. Y3 plus Y3, 2Y3. Y4 plus Y4, 2Y4. Y5 plus Y5, 2Y5. Y6 plus Y6, 2Y6. Y7 plus Y7, 2Y7. Okay? Here, there is going to be Y8 plus Y9 too. The last trapezium. So here will be 2Y8 plus Y9. So generally, from trapezium rule, area under a curve that's integral between x1 and x2 of y with respect to x is half the height into y1 plus y2 plus y plus 2y2 plus 2y3 and so on up to 2 times y minus 1. Y minus 1 means second to the last term. So all the ones in between will be 2 times plus yn. So the first term and the last term will have coefficient of 1. All the other ones in between will have coefficient of 2. From the equation of the curve, you will have various values of x. And from the various values of x, you get the various values of y. And the height will be the difference in the x values, x2 minus x1 over n minus 1, where n is the number of coordinates.